In this video, we're going to talk about one-sided limits. So in the last example that we had, what we did was we calculated or used a numerical table to calculate the limit as x goes to 2 of the floor of x, so the floor function. And what we found was that the limit as x goes to 2 of the floor function did not exist. When we looked at those limits, when we looked at the behavior as on the right side of 2, right, we saw that the output values were all equal to 2. And over on the left side, when we looked at the output values that we got, that they were all equal to 1. And so since the limit only cares about what's going on from both sides, we had to just say that the limit didn't exist, because the stuff that was going on the right did not match what was going on the left here. So when that happens, the limit doesn't exist. So we can see, though, that there's some definite stuff going on from the left side and from the right side. And so what one-sided limits are, it's just the limit when you only care about what happens on one side of the function. So one-sided limit, here's the definition, and notation-wise, you can see that there's a little minus sign in this superscript position. This minus does not have anything to do with whether a is positive or negative here. It just means that we are going to calculate this limit only from the left side. We are only going to use values of x that get closer and closer to a that are on the left side. Those are values also, right, that are less than a itself. And then see what happens here. So if the values of f of x get closer and closer to some fixed number L, then what we will say is that the left-hand limit of f of x is equal to L. We have a similar definition for the right-hand limit, and again, in the right-hand limit, we're going to distinguish that from the left limit and the two-sided limit with a little plus right here. So again, that plus has nothing to do with whether or not this value right here is positive or negative. It means that we are only going to consider values of x that are on the right side of this number a and look at the limit there. So, okay, so and if that limit exists, we'll say the right-hand limit of f of x is equal to L. Okay, so originally when we first started talking about limits, we were really talking about the two-sided limit. So that's why I kind of said before to you, you need to look at what goes on the left and on the right. And so now we're going to add two more limits to what we've already have, and that's the one-sided limit. So as of right now in the class, we have three limits going on. We have the two-sided limit, and then we have the two one-sided limits, the limit from the left and the limit from the right, or the left hand and the right hand limit. So, okay. So going back to our example here of the floor function, we are now going to look at the limit from the left, the limit from the right, and the two-sided limit. So going back to our tables here, and we're first going to take a look at the limit from the left, right? The limit from the left here, 1.9, 1.99. So we are now taking values of x that get closer and closer to x, but restricting ourselves to the left-hand side. And we can see that, yes, there is a definite pattern right there. The output values are all exactly equal to 1 there. So what we would say is that the limit as x goes to 2 from the left of the floor function is equal to positive 1. Okay? So that's the left-hand limit. Next, we're going to look at the limit as x goes to 2 from the right. So we're going to look at these values here. These values are getting closer and closer to 2, but they are all on the right of 2 on the number line. They're all greater than 2, but they are getting closer and closer to 2, and we can see that their output values are exactly equal to 2 in this case. And so what we would say again is that the limit as x goes to 2 from the right of the floor function is equal to 2. So again, these limits are just looking, this one from the left side, this one's just looking on the right side. And the other one, which we already calculated, the two-sided limit now is how I'm going to refer to it. when there's a question about it. So the limit as x goes to 2, the two-sided limit of the floor function does not exist, as we mentioned. Right? Remember, the two-sided limit means that as you approach x, as you approach 2, right, and you plug in values that get closer and closer to 2 into the floor function, your output values get closer and closer to some number. We can't, again, say that that happens, because if you restrict yourself from the left, the values are going to get closer to 1, and if you restrict yourself to the right, the values are going to get closer and closer to 2. So there is not one number, one single specific number in which we can say that the values from both sides get closer to. Can't be 1 because the values on the right side get closer to 2, and it can't be 2 because the values on the left side get closer and closer to 1. So the two-sided limit in this case, again, just does not exist. So there is a definite relationship between one-sided and two-sided limits. The short, succinct way to state it is this theorem right here. The limit as x goes to a of f of x equals L, so the two-sided limit is L, if and only if both one-sided limits are equal to L. Okay. So that little statement there says a lot of things, and so in the next slide, I'm just going to go over each individual thing specifically and cover it case by case. Okay, so under reasonable assumptions, number 1, if the two-sided limit exists and is equal to L, then automatically you know both one-sided limits, right? If the same thing is happening on both sides, then that same thing has to happen on the left and on the right. Okay, so that's number 1. If the two-sided limit does not exist, right, what that means is that either the one-sided limits both exist but are not equal to each other. So that happened in the previous example, right? In the floor function, the left-hand limit was not equal to the right-hand limit, and so that meant the two-sided limit does not exist. But there is also another way that the two-sided limit might exist, if at least one of the one-sided limits does not exist. We haven't had an example like that, but there are plenty of such functions like that where the one-sided limit won't exist. And so if the one-sided limit doesn't exist, automatically you know that the two-sided limit doesn't exist. Just because the two-sided limit doesn't exist, though, means either one of these things could happen, so you're not really sure. If both of the one-sided limits exist and are equal to L, then you automatically know that the two-sided limit has to be equal to L. If it's doing the same thing on the right and on the left, then you know from both sides it's doing whatever it is the two one-sided limits are doing. So, and finally, if the one-sided limits exist but are not equal to each other, or if one of the one-sided limits does not exist, then you know that the two-sided limit does not exist. So those cover most of the cases that we care about in this class, or situations that are going to come around. And so the next few examples are going to illustrate a lot of those different behaviors there.